break this problem down into the 3 questions, you'll do number 1, we'll tighten it up. You'll do number 2, we'll tighten it up, and number 3. So after 1 ABC, you're gonna take a break. This is population of the United States from 1790 to 1860. Okay, this function works for 1790 to 1860. What you're going to do is use the function to come up with some information and then make a prediction and see if it works for our prediction. So 1, ABC, let's go. 2, 1. Eyes on the board, mouths closed. So 1790, who can tell me how many people and how they know? Hey, Kai.
4,000.
Nice.
That's close.
Wait, what?
4 million people.
Oh, that's why.
Yeah, because it's 4,000 in thousands.
So I was like, what?
Okay, so for 1860, how are we going to find that one? What? So this one, we could just look at it. 1860, we need to use the function, right? How many years? 70 years. So I'm going to take my 4,000 times 1.031 to the 70th power. So I get 4,000 times 1.031 to the 70.
I got.
And we get 3389741 0.5.
So I have
33.9 million people.
Wait, don't you have to add the 1,000?
No, you don't.
I did add the 1,000.
I put 2 commas.
I moved my decimal 3 times just from.
half of a person.
Who can tell me the annual percent increase and how they know?
3.1% increase annually.
Yep, and we get that from the growth factor of 1.031, right? Okay, 2017. Brendan, tell me what to do to get that one.
So there's 227 years in between 19
Whew.
or 17.
Okay, so if you did this, we got a number that is large, right?
Big number. Actually, it's just 300 million.
I got 409050578.
It's close.
So 4 billion people in the United States?
No.
No,
Like 330 million.
Yeah, 350 million.
it's cap. How aren't there like 200 some million?
350 about.
Okay, so we're just off like 3.5 billion. No big deal. Real close.
That's not what I got.
Yeah, now we got
So,
a pretty big military.
Does this model hold true till present time at all? No. So there's lots of reasons why this probably doesn't hold true.
What's death?
No, population still grows.
Well, I know, but people die.
The Industrial Revolution is probably the big thing. But
What about death?
what you're going to work out with your problem now is getting a percent increase to model a decade instead of just a year, and then write an expression or equation showing that. For 2B, there's actually 2 different ones that'll work. So if you get one done, try to find a second one that works. I'm looking for some help getting the percent for a decade. I'm more interested in how than what it is. Sean, what am I going to do?
So we were trying to figure out, so if it was 3.1% before, we were trying to figure out
Yeah.
if we move the decimal to the left or to the right.
Okay, well, if I'm multiplying by growth factor 1.031, how many times am I doing that in 10 years? 10 times. So this is what I'm going to do. 1.031 to the 10th will pump out 1.35702 other stuff. So this tells me for a decade my growth factor is about 35 not growth factor, but my percentage growth is about 35.7. So when I go slap that in my function for a decade, the first way you might consider doing it is this. 4 million people times 1.357 to the number of decades. Because this 35.7% is a decade. The other function you may consider, or expression, is 4,000 times 1.031 to the 10th to the decade. These are equivalent, right? This portion right here is this portion. This one's kind of nicer to use if you like. I know how many decades. I think this one does a better job explaining the situation of the annual, but they pump out the same thing, right? But they kind of like paint a different story, even though they're equivalent. It's kind of cool. So you're gonna work next on 3A and B. You're looking at a century next. All right, guys, on the board. Let's go. There's two different ways to get the century. I prefer this way. 1.031 to the 100. And I just prefer that one because if you did the 1.357 to the 10th, we rounded to get that percentage. So the 1.031 would get us closer. Yeah, it's going to be more accurate. But either way, the right idea.
I got 21 point. Yeah, that's right.
So I get 21.177. Now, this is the growth factor, right? The challenge for the percentage is, what percentage is no growth?
100.
100. So we need to take away 100%. If we take away 100% from this, that leaves us with 2,017.7% increase for a century. So you'll notice we messed with this digit. No, this one.
Oh, I got
But you always have to take away 100%.
Well, if we're going from growth factor to percentage growth, yes. Because 100% in your growth factor is no change. Times 1 is no change. So if our growth factor is 21.177, that's 2,017.7%. Okay? Now let's write our function a couple different ways. I got 4,000. The first way you could think of it is 1.031 to the 100 to the century.
That's what I did.
The other way you could do it is 4,000 times 21.177 to the C. They're equivalent, right? Same thing. This is still telling us the annual, so I kind of like the story this tells. But if I'm actually finding the answer, I like this one. So different reasons for different ones. I'm going to tell you these directions. Just listen carefully. You should also read them. So you're going to sort these expressions into groups. There's going to be 3 different groups. Oops, one sec. Okay. Now, one important. One group contains more than 2 expressions. So there's a group of 3. One does not have a match, which means there's a group of 1 that you're going to write an expression for. So if there's a group of 3 and a group of 1, that also means there's a group of 2. It's not a 1-to-1 match. There's a group of 3, a group of 2, a group of 1. Get after it. So the first one I looked at is this. I just said I'm gonna try to group this. And looking at my equation, my 7% nominal interest is being divided by 12. What does that tell me?
Every month?
Every month. Okay? So that brings my eyes to right here. Now I'm going to double check that my exponent's good. So if it's happening every month for 6 years, 12 months a year, for 6 years is how many times?
72.
Okay, that one checks out. Now you might also notice though, this third one. 7% nominal divided by 12 tells me monthly. For a year times 6 years, that's still 72 months, right? So all 3 of these things are the same. You guys follow?
No, explain the last. I don't get.
So this is for 1 year if it's for 12 months, right?
Mm-hmm.
Well, 12 to the 12 to the 6 is 72 months total, which is
So, but I did 12 times 6. Would it be 12?
yeah, that's 72.
Oh, it is.
Yep. So
Okay.
this second one right here, I'm going to put a box on it. If I'm dividing by 2, my nominal interest of 7%, if I'm dividing that by 2, what does that mean? How often is it compounded?
It's every 2 months.
No, every 6 months.
Twice a year.
So it'd be semi-annual. Yeah, that makes sense.
And let's make sense to the exponent. If it's twice a year for 6 years,
12.
that's 12 times. Just for fun, we could also write that as 1,000 times 1 plus 0.07 divided by 2 to the 6 Oh, that 6 should have been inside. To the 6, or squared to the 6. Sorry. We could also write it like that. Okay, and then the one that has no friends. That one. Let's write it. $1,000. My interest is 1 plus 0.07. Now, how much am I going to divide it by if it's every 2 months? 6. And if it's 6 times a year for 6 years, how many times is it going to happen? 36. Some of us have wrong answers and we can work with them. That's cool. We could also write it as this. To get to 1 year, we'd have to do that how many times?
6 times. That's what I did. And then I did another 2.
And then to the 6. That's another way we could write the same thing. Yeah. Awesome.